Hey guys, it's Robotics, and this is my next video. And today, this video is going to be about end effectors. As probably in this kind of short series in my YouTube channel, it's about like the skeleton of the robot, which we talked about in my 3 videos ago, which was the microcontroller, which sends code to the actuators and the sensors, and those eventually lead up to the end effectors. So I'm going to be talking about end effectors now, and my next video will probably be about microcontrollers. Microcontrollers are a bigger topic to talk about, so I might divide it up into multiple videos. So yeah, end effectors. So in this video, I'll be explaining what end effectors are, and I will be giving a few school robotics examples. So let's just review what an end effector is. So an end effector is basically the hardware that allows the robot to manipulate objects, like change them, like or move them around. So for example, if you want to pick up a ball, then you build a mechanism, which is technically an end effector, and you can pick up the ball and move it around. Even if it just moves it to a couple millimeters to the side, you're still getting a task done. As long as you get a task done, it's still an end effector. And end effectors come in all sorts of shapes and sizes. So like this claw over here, you see this claw? That's also an end effector because it can move up and open and close with the help of this actuator. And so the claw can open and close. And that's an end effector because it can pick up like a cube, for example. So why do we need end effectors is because they're basically the main mechanisms of the robot. I would say that they're probably mostly like the skeleton of the robot. The brain is more of the microcontroller. The actuators are more muscle based because they can help you move, like kind of like the skeletal system. And you have your sensors, which are like your 5 senses. So yeah, end effectors are the main mechanisms on the robot, and not having any end effectors would be like not having any bones. It's like no defined structure for the robot. So the robot wouldn't be able to perform any tasks, at least not efficiently. Of course, you can have a soft bug, which doesn't need to have end effectors, but still, soft bugs are not really that much of a robot, but we just count them as one. So let me just show you a few types of end effectors if you're still confused. So we have the simple claw over here. It's a basic end effector that can just pick up and drop objects. It's good for picking up objects that are still like squares instead of something that can roll around. We have the accumulator, which is a type of end effector because it interacts with the environment by picking up objects. It is differentiated from the claw because of its ability to take in more than one object and place it in a storage. So the accumulator is different because you see here that we have these mechanisms, kinda. Sorry for the bad drawing, but we have these mechanisms which can help bring in, like this accumulator can help bring in a cube over here, like this platform, and that's basically an end effector. And then with the simple claw, it's more based off on one object. You can just pick up one. And then you have the scoop, which is another end effector because it can scoop up certain objects and move them around. Like this, it can scoop them up, put it against the wall, scoop it up, then put it somewhere else. And also one that I didn't mention in the other examples, but still counts, is this just a regular simple lift. Basically, it just uses these 2 gears, and it moves in a non-linear movement, which means it doesn't move in a line, it moves kind of in like a curve. So now we have our elevator, which is a different type of end effector. It doesn't pick up anything, but it moves the mechanisms, which are, for example, picking something up. This is a reference to Ringmaster. You can see here these rings. So the claw is picking up these rings, while the elevator over here, is picking up the claw. So it still counts as an end effector because it is being used by actuators and it still has code going. 4-bar lift. The 4-bar lift is also an end effector because it is a mechanism powered by a motor that moves up and down. So it is a little different from this 2-bar lift, kind of a 2-bar lift. This is a 4-bar lift. So it is a little, I guess, yeah, it is more linear, I would say. Not as much linear as the different ones. You also have a 6-bar lift, which has another 2 bars coming out here, and then another 2 bars sticking out. So kind of like, this is basically the 4-bar lift. I would say it's the main one. So let me show you an example of End Effector. This is in Ringmaster, also known as a reference. And basically, give it a second. Basically, it's the YouTube video is showing these people. They're driving the drivetrain, and it's basically picking up all sorts of these Ringmaster rings down here, different colors and all, which can be sensed by the sensors, but still, yeah, it's picking them all up and through an accumulator. So let me go to the right part. Picking up all through the accumulator, which bringing the rings into a storage kind of place, and then they can be deployed onto these places to get points. So now let's talk about robot compatibility, not robot effectiveness, robot compatibility. So number one, robot compatibility is that the robot should probably be more equipped with more than one end effector. This allows the robot to manipulate more objects at the same time and can often increase the efficiency. Basically, instead of, as I can just refer to this, instead of creating just the drive base, for example, or no, instead of just creating the elevator, they created the elevator and some sort of storage mechanism that can later deploy. So basically, it'll be more efficient. To sum it up, it'll be more efficient to have more than one end effector. You can have 2, 4, because it's hard to do it with just one. Especially if you're moving around a robot and have to pick something up, you definitely need more than one. So robot compatibility number 2 is that the end effectors must also be able to interact properly with the objects on the field. For example, if there are like spheres and balls to pick up, then a simple claw would not be the most efficient. A scoop would probably be more necessary. Like over here, this is probably going to be more necessary than something like this to pick up a sphere. Picking up a sphere would just probably move away from the simple claw. So it's good to use something that actually works and is capable of interacting with the environment better. Or in this case, rings, you don't want to use something too thick to pick up the rings. You don't want to, they use some Dex IQ objects called standoffs, which are really thin and, not thin, more spherical, and can pick up these rings easier. So now let's talk about the robot's effectiveness. Of course, we've talked about this in previous videos, but basically, robot's effectiveness is whether a robot is successful or not. And we talked about actuator, sensor, and end effector and microcontroller effectiveness. So yeah, because of this, end effectors are 25% of the robot's success and probably should be included in the robot. And yeah, I would really recommend that robots should have end effectors. So yeah, thank you for watching this video and be sure to subscribe and like.